throughout the year you're going to be finding problems that ask you for an exact answer, or they may say to write your answer in simplified radical form. This is particularly going to come up when we're working with radicals, so things like distance formula and Pythagorean theorem. So it's something you've seen in Algebra 1, but let's go ahead and review it in case you need that refresher for how to simplify radicals. The big thing is no decimals allowed. Don't you dare think about giving me decimals as answers if they say to simplify or give an exact answer. So let's take the square root of 80 for example. It's not a perfect square. If you were to type it in your calculator, you're going to get some big long irrational decimal. I don't want that. Instead what we're going to do is do a factor tree. So let's go ahead and think of two numbers that 80 can be factored into, two numbers that multiply to give you 80. Off the top of my head, I come up right away with 8 and 10. Now you might be thinking 20 times 4 or some other variation. It turns out that it doesn't matter how you factor this, you'll always end up with the same final answers when you're done factoring, which is one of the kind of cool things about numbers, I think. You keep factoring until you can't factor anymore. So for example, 10 can still be split into 2 times 5. Now 2, if I tried to factor that, would only factor into 2 and 1. 2 is a prime number. Same with 5. I stop factoring when I get to prime numbers. 8 though is not prime. 8 can be factored into a 4 times a 2, and then finally the 4 can be factored into 2 and 2. So I end up with this factor tree that has these final branches or leaves of a 2, 2, 2, 2, and a 5. And again, no matter how you start factoring, you'll always end up with those same 5 numbers. So I always give a story with these. If you've been in class, you know the story. We have this house. The house is my radical symbol. What you're doing is you're looking for pairs. So for example, pairs in your final branches, the final leaves. So I see right here I have a pair of 2s. Now just like in real life, if you have someone to pair up with, a friend, a boyfriend, a girlfriend, that pair gets to go out of the house. So yay, that pair of 2s is out of the house. I have a second pair of 2s right there. So I'm going to put another 2 out front. Now anytime there's more than one pair either out of the house or in, those pairs multiply together. Sadly in life there's also people that have no one to pair up with sometimes. That 5. No one to pair up with, no one to go out with. So that 5 is sadly stuck at home. So to simplify that then, since I've got the 2 times 2 in front, let's go ahead and just make that a 4 and then square root of 5. That becomes my simplified answer. An easy way to check these is to take out a calculator at this point, plug in the square root of 80, get a decimal, type in 4 square root of 5, and you should, if you've done it right, get that same exact decimal. And that's the answer that I would give if they ask me for an exact answer or a simplified radical form of the answer. If you get it, you can stop watching the video. If you want to see a few more examples, I'll show these next 3 real quick as well. Again, exact answers, so I'm going to be using a factor tree to break this down. 2 numbers that multiply to 45 are 9 and 5. 5's prime, it can't be factored or broken down anymore. 9 can become a 3 and a 3. Again, what you're looking for are pairs of the final branches. The non-prime numbers like the 9, we don't care about those. So I got a pair of 3s. The pair of 3s get to go out of the house. Just that one pair of 3s. Again, that 5, poor old 5, has no one to pair up with, and it's stuck at home. So my simplified answer should be 3 square root of 5. When we get to something like the square root of 100, I always ask people to just stop. Stop thinking. Don't listen to. Don't remember all this stuff I told you. Don't worry about calculators, exact answers. Just stop and answer the question, what's the square root of 100? And hopefully, right away, you just say, well, it's 10. So if we have a number that's a perfect square, you don't have to do a factor tree. Just go ahead and say the square root of 100 is 10. If you did try to do the factor tree just to see what happens, we could break that into 10 times 10. Now, I know 10's not prime, but if I circle that pair of 10s, that pair of 10s gets to go out of the house, so that's out in front. And if you look, there was nothing that was left behind, so there is nothing left over. It's just 10. That's why these numbers are perfect squares. That's why 100 is a perfect square. And then finally, one other example with 14, I can break that down into 7 times 2. And there's no pairs of anything. So nothing gets to pair up, nothing gets to go out front. All that happens is these 2 single numbers, they stay at home and multiply, and don't think too much about that, but they're going to stay back at home and just end up with square root of 14. That can't be simplified, or you could say it's already simplified.